Now that we've reviewed factoring, we're going to dive into multiplying, dividing, adding, and subtracting rational expressions. In Lesson 8.4, we'll multiply and divide. A rational expression is an expression that contains a polynomial in the numerator and denominator. We'll identify numerator as n of x because it's going to be a polynomial, maybe possibly a function, and then our denominator as d of x. Now, examples of this could include something as simple as 4 divided by 5x. Another example would be 2x plus 3 divided by x minus 7. And even another example could be x plus 4 times x minus 1 divided by x minus 1, x plus 3. These are all different examples of what are known as rational expressions. When we're asked to simplify a rational expression, the first thing we're going to do is factor. And we'll factor both the numerator and denominator completely. Then what we have to do, because it's a fraction, is we're going to have to state restrictions in our domain. And this brings us back to Chapter 5. So remember, d of x can't equal 0. And like I said, this is from Chapter 5. If possible, you're going to try to reduce the fraction. But we can only reduce something if they have a common factor or they're an exact match. So we have to be really careful in this last step. Write an expression that is equivalent to x cubed minus 5x squared minus 24x divided by x cubed plus x squared minus 72x. When it says write an expression that's equivalent to, this is really just saying simplify. And we have to be really careful here. It's common to want to do something like this because I see the exact same thing on top and bottom. But that doesn't apply when there's addition or subtraction. So we really do have to follow our 3 steps. Step 1, factor. I noticed that in that top polynomial, n of x, all 3 terms have an x in common. So what we can do is factor that out. And that would give us x squared minus 5x minus 24. But then we can keep going. What are 2 numbers that multiply to equal 24, or actually negative 24, and add to get negative 5? We could do positive 3 and negative 8. They would multiply to get negative 24 and add to get negative 5. We'd have that x on the outside, and if we do x plus 3 and x minus 8, that's a factored form for that numerator. And then we get to do the same thing in the denominator. So same idea. I'm going to take everything that's on the bottom. And again, I see we have an x in common. I'll take that out first. And then recognize we have x squared. We'd have plus 1x minus 72 left over. And again, we could break that down further. 2 numbers that multiply to get negative 72, but then technically add to get positive 1. Lots of numbers going to 72, but what comes to mind right away for me is 8 and 9. They would easily get us positive 1 if we make the 9 positive and the 8 negative. So then this is going to be divided by, again, we have that x out in front. If we do x plus 9 times x minus 8, that's the factored form for the denominator. And that's all you do in step 1. We don't do anything else in that step. Step 2, we have to state restrictions for our domain. And remember, the rule for the domain is that the denominator can't equal 0. Well, if you notice, we've got 3 parts to our denominator. I'm just literally going to plug in that whole thing. X plus 9, and x minus 8 can't equal 0. And then we just set each part equal to 0 separately. The outside x just right away can't equal 0. That's pretty easy. X plus 9, if we say x plus 9 can't equal 0, then x can't actually equal negative 9. And then the x minus 8, if we say that that can't equal 0, then x can't equal positive 8. All three of those terms are going to be in our domain. X can't equal 0, -9, or +8. Once you state your restrictions, you can then go back to that original problem, step 3. Since I've already have it factored over here in step 1, I'm not going to rewrite it, but you're welcome to do so if you want to remember the process. I notice right away there's an X on the outside, on top and bottom. These are the exact same, so we can cross them out. Now I have X plus 3, but there's no other X plus 3 that's an exact match, so that's kind of stuck in that parenthesis. I also see there's an X minus 8 and another X minus 8. If they're the exact same, they can cross off. What we have left over then is a parenthesis with X plus 3 and a parenthesis with X plus 9. If they're not the exact same on the inside of the parenthesis, we can't break apart individual pieces of the parenthesis. Like we can't cross off the X's or reduce the 3 or the 9. There's going to be a parenthesis in the numerator and denominator, and that's as simplified as that expression can get. Let's try another one. What is the simplified form of the rational expression? 4 minus x squared over x squared plus 3x minus 10. Step 1, let's go ahead and factor. Now it's a little tricky with 4 minus x squared. It is a subtraction problem, and both 4 and x squared are perfect squares, so that's actually factorable. But the order is going to matter. Since 4 is first, we have to split that apart into 2 times 2. And the x squared is second, so we have to split that apart. And then one of them is plus and one of them is minus. Okay? But recognizing that usually x is first, it's not a bad idea to rewrite this. So let's do that right away. Now, 2 plus x is the exact same as x plus 2. Those can be written in either order because it's addition. But be careful on that second one. If we rewrite the order for the second one, it has to be negative x plus 2. Order matters when you subtract. So if it's minus x in the original, the x stays negative. As long as you can remember that, we should be in great shape for this one. Now in the denominator, we've got x squared plus 3x minus 10. Let's look at that negative 10. What are numbers that multiply to get 10 that we could manipulate in some way to get positive 3? Well, I know 5 and 2 would get us 10. Which number would have to be positive in order for us to add them and get 3? I think the 5 would have to be positive. This means we would split apart the x squared into x and x, and then we'll have plus 5 and minus 2. And for this one, I think that's all we can do, so I'm just going to go ahead and rewrite that over here, and that's step 1. Again, don't do anything else in step 1 until we get to step 3. Now, step 2. Remember, the denominator can't equal 0. So we have to figure out the values for x that would be true for that. So the denominator is the purple right here. That means I'm going to set x plus 5 and x minus 2 not equal to 0. If I do the x plus 5 and we move 5 over, whoops, I almost put plus there, careful, see? Put minus 5 on each side. We know that x can't equal negative 5. And then for the other one, if I have x minus 2, we also know that x can't equal positive 2. Again, I've said this before, but take the time to solve both of those because you really want to make sure that you've got the correct answer for the work that you're putting into it. There we go. Solve that. And then we get to step 3. So when we initially look at this problem, there really isn't anything that's the exact same. We can't do the x plus 2 with the x plus 5 or the x minus 2, but I'm noticing something about that second parenthesis. You may or may not see it, and that's okay, but there's something that we can do in this part right here. So I'm going to take that x plus 2, the first one, and just write it as is. But then in that second one, I'm going to factor that negative out. And what that will do is it's like multiplying by negative 1. It'll make the x positive, but the 2 will change to negative. And here's another thing I'm going to do, everybody. I'm going to put that negative 1 in parentheses so that it doesn't look like subtraction. We don't want to go through all this work and then misinterpret what that's doing. If we factor out a negative 1, it's technically still multiplication. And now if I put the denominator underneath, the x minus 2's are a matching parenthesis, which means we can reduce that part of the fraction. Now for the numerator in our final answer, this negative is just a coefficient. I'm going to put that out in front. You can write -1 if you want, but I'm just going to put negative x plus 2 over x plus 5, keeping everything in parentheses. If you have just a polynomial on top and bottom, like your n of x and your d of x, and you're asked to simplify, these are the 3 steps to follow. When asked to multiply rational expressions, the process is going to be really similar to what we did up above. Step 1, you're going to factor all the numerators and denominators. You may have 2 fractions or even 3. And then you'll state the restrictions in the domain for all denominators. No matter how many denominators or fractions you have, remember all the denominators can't equal 0. If you have a product or multiplication, any numerator that matches will cancel out with any denominator. So it doesn't have to be the top and bottom of the same fraction. And then last but not least, when you have a final answer, you may have more than one parenthesis on the top or bottom. Leave your answer in factored form. It technically isn't incorrect to FOIL, but if you do that, it lends to it, or it kind of sometimes leads to errors. So if you can leave it in factored form, it's less work and you're less likely to make a mistake. All right, let's try a couple of these and we'll be done for the lesson. For our first example, find the product of 2xy divided by z and 3x squared over 4yz. So if we have 2xy divided by z, nothing actually factors. Remember, things are only factorable when there's addition and subtraction involved. But if we're finding the product, I'm just going to put a times in between. And then check out the second fraction, 3x squared over 4yz. And again, nothing factors here. So step 1 is kind of done for us. Yeah, thanks, step 1. There we go. So there's step 1. Step 2, again, we're going to state any restrictions on our domains. I see I have a z and the 4yz. So for that first fraction, z can't equal 0. Super easy. In the second fraction, 4yz can't equal 0. Well, the 4 is just a number, so that's not going to affect the 0 at all. But the y can't equal 0 because y times z, if either one of them is 0, the product is 0. And z we've already calculated over here. So we really only have 2 parts to our restricted domain for the z and the y. Now step 3. Again, this is kind of a little tricky because there aren't any parentheses to focus on. So if we have 2xy times 3x squared, I'm just going to put that all over z times 4yz. So if I look at things that would cancel out here, I notice that not a lot actually, everybody, is going to cancel. I see I could cancel out this y and this one, but if the x's are on top, they don't cross off. And the z's on the bottom also don't cross off. So then I notice we've got 2 times 3 would be our 6, and x times x squared would be x cubed. On the bottom, I've got a 4, and then a z times a z, which is z squared. But now I recognize we could reduce this part of the fraction because 6 and 4 are both divisible by 2. That would give us 3x cubed over 2z squared. And that is the simplified product for this problem. That last example was pretty tame. This next one is a little bit more complex. What is the simplified form of 5x over x plus 3 times x squared plus x minus 6 divided by x squared plus 2x plus 1 times x squared plus x over 5x minus 10? Yowza! All right, there are 3 fractions being multiplied. Step 1, let's factor each numerator and denominator. In the first fraction, 5x divided by x plus 3, at least nothing factors here. But I am going to put that x plus 3 in parentheses in the denominator. Let's stay in the habit of that. In the second fraction, we've got x squared plus x minus 6. So what are two numbers that multiply to get negative 6 but add to get positive 1? We could do x plus 3 and x minus 2. That would give us that product. And then in the denominator, what are two numbers that multiply to get 1 but add to get 2? Well, there's not a lot of choices there. It's going to be 1 and 1. Therefore, it's x plus 1 and x plus 1. And then we get to that last one. And that last one's kind of tricky on the top because we're missing that last term. We have x squared plus x. In this case, notice each term has an x in it, so we can take that out as a common factor. And then we'd have x plus 1 left over. And in the denominator, we don't have an x squared to try to factor, but 5 could come out of both 5 and 10. That would be another common factor, and we'd have x minus 2 left over. Make sure you're okay with that before we move on to the next step. Speaking of that next step, we're going to talk about the domain. That's step 2. Remember, all the denominators can't equal 0. In that first fraction, we've got x plus 3 can't equal 0, and that means if we move the 3 over, x can't equal negative 3. Now in that second fraction, we have two x plus 1s. That means the domain will be the same for both of them. We don't have to set it equal to 0 or not equal to 0 twice. So if I just do x plus 1, and I don't know why I put that in parentheses before. You don't have to put it in parentheses for this part. So we do x plus 1 can't equal 0, and we move 1 over. X can't equal negative 1. And for that last part, remember the number itself isn't going to affect our domain, but the parenthesis will. So this means x minus 2 can't equal 0. And if we add 2 to each side, x can't equal positive 2. All three of these are our domain restrictions for this product. And then we get to step 3. Step 3 is going to be our cancel step. So let's take a look at number 1. We've got greens, pinks, and purples. Do you see anything in the numerator and the denominator that's exactly the same? I can see this x plus 3 right here, and this one would cross off. We have an x minus 2 and an x minus 2. That crosses off. We don't have a plain x on the bottom, so that doesn't go anywhere, but this x plus 1 can cancel out with one of these down below. Do we see anything else? Get this, everybody. In that first fraction in the green, this 5 and this 5 on the bottom are an exact match. And the 5 with the green isn't with a plus or a minus, so anything that's a product can cross off with anything else. Now, can we tell what we have left over? I see an x on top and another x on top. So if we multiply those two together, we would get x squared. In the bottom, the only thing that's left is that x plus 1. And remember, let's put that in parentheses to stay consistent, and that would be your product. I think we're going to save this last example for class. So feel free to re-watch this video if you need any more clarification.